This is lesson 50 of the Quantum Mechanics, a mini lecture series, vectors part 2. So in the previous video I talked about vectors, what a vector is, what vector components are, what basis vectors are. So suppose I have a vector v, I can express it in terms of its components, a v1 vector plus b v2 vector. Okay, and a and b are just numbers, they're constants. v1 and v2, these are also known as the basis vectors. Okay, they form the basis for the vector v. Now when we do this, v dotted with v, okay, this symbol here means dot product, okay, which loosely means multiply, even though it doesn't. Okay, it's called the dot product. When we do this, we find that that's equal to the vector squared. Okay, in other words, this is equal to the length of the length squared of the vector itself. If we find that this results, then the two vectors are said to be orthogonal. Okay, they're at right angles with each other. How does dot product work? Let me show you. Suppose you have a vector v from before. Okay, let's call this v sub x. Let's call it v alpha, v beta. No, I should say, let's just call it v, right? The dot product of its with itself, I'll write it out like this. I'll take the dot product. Here's how I would do it. You simply multiply each component and add. All right, so AV1 times AV1 is just, what we do is AV1 times AV1, so you multiply these two components, plus BV2 times BV2. It's like multiplying the x and y components, okay, as an analogy. So you'd get a squared v1 squared plus b squared v2 squared, okay, which is just the vector squared, the original vector squared. So that's the idea of a dot product. You can even do it with numbers. Let's suppose I've got something like this, dotted with 2, 3. It's the same idea. Take the x components 4 times 2, multiply them, and then add the y components 5 times 3. 4 times 2 is 8, 5 times 3 is 15. 8 plus 15 is 23. And that's how you take the dot product. There's also the concept of unit vectors. Okay, these are vectors which look like this. So suppose I have u hat and u2 hat. So this is called the hat symbol. Okay, this implies that each of these vectors, so if I take the dot product of, let's say, u1 with itself, and I get 1, each of these vectors has a unit length. Okay, it's got unit length, in other words, unit norm. Actually, don't worry about that. Unit length for now, right? Okay, these are unit vectors, and they typically form the basis of a vector. Let's say we've got vector v. So from before I had this, okay, what it should actually be is this u1 hat plus b u2 hat, okay? These basically tell you directions. They tell you the direction, right? u1 typically corresponds to the x-axis, u2 hat typically corresponds to the y-axis. And the length of a vector, also known as the norm, may be defined as the square root of the vector dot product, the dot product of the vector with itself. Now, but we seem to come across a problem here, if you really think about it, okay? If you get a negative number, let's say, okay, you can't take the square root of a negative number. And as such, we need to redefine this as follows. Absolute value of the vector v is the square root of v vector star dotted with vector v. And this hash symbol here, this star, it means take the real and positive, okay, it could even be 0, part of the vector. Okay, and I'll do some examples in the next video.